Hello and welcome to the laboratory of Dr. John Pellegrino. My name is Paul Canny and I'll be showing you around the lab today. This is a nanoscience and research laboratory with a focus in membrane technology, and what we're doing is trying to create nanometer-sized features on membranes. The reason we're doing this is because normal membranes have the tendency to clog up and need to be cleaned or replaced often, but what we've done is been able to imprint nano-sized ridges onto these membranes, which then create eddy currents and cause less clogging of the membranes. This is good news for commercial users because it'll mean money saved in the fact that they won't be spending time cleaning or buying new membranes. However, the problem is that this is still at the laboratory level and there's not a good way to produce a lot of this membrane material. So what we're doing is trying to validate a roll-to-roll process of creating membranes and getting this out into industry. So let me take you through our process really quick. What we're doing is we're starting with a 2" by 2" silicon stamp, and this silicon stamp actually has nano-sized patterns on it, but this is incredibly costly and time consumptive to produce. It takes a lot of weeks of back time in order to ship one of these out, and each one of these stamps costs $2,000. So what we need to do is take this surface area and blow it up to a much larger membrane surface area that can actually be used for commercial uses. So what we do is we take this silicon stamp and we put it into our nano imprint lithography machine. What this does is take a pressure head here and a heating head down there, and it applies a high heat and a high pressure for a duration of time, which transfers those nano patterns into plastic materials. The one that we're using right now is called Ultim. It is in the polyether imide family and is a very strong thermoplastic material. And what we're creating is sort of an intermediate stamp, such that we don't have to use our master stamp. We can use an intermediate layer in which to stamp onto our membranes. So after the nano imprint lithography machine, we take it over and we plug it into our roll-to-roll machine. As you can see in there, it's got rollers backed up by bigger rollers, and this machine accomplishes a very similar task in applying high heat and high pressure, except instead of using the master stamp, it uses this intermediate substrate Ultim material with the nano-sized features in it, and it imprints those into this material. This is polysulfone, and it is our membrane material. It's very useful in food and beverage industries, medical industries, as well as desalinization processes, pretty much anywhere that you would need to filter out a liquid or some other type of material. So what we do is run our polysulfone material along with our Ultim material in contact through these rollers, and we can pretty much just run a continuous stream of nano-featured membrane through this roll-to-roll machine. After this, we validate the results using this. This is a milk filtration experiment, so this is a good example of the food and beverage industry that could use our membranes, and we're actually in conjunction with a cheese producer in Denver that wants to start using nano-featured membranes. So we're hoping to validate the roll-to-roll process of creating nano-stamped membranes, as well as get this out into a commercial use and start being able to use nano-featured membranes. Thank you, and I hope to see you in the future.